All right, now we're going to investigate when trig ratios are positive or negative based on what quadrant they're in. So, if you think about it, x and y are positive in quadrant 1, x is negative and y is positive in quadrant 2. They're both x and y's are negative in quadrant 3, and x is positive but y is negative in quadrant 4. So if we're taking a look at, and one other thing, r is always positive. So if we take a look at, let's say, for example, if I took a look at cosine in quadrant 2, cos theta is equal to x over r. Because x is negative in quadrant 2 and r is always positive, the whole fraction would be negative in quadrant 2. But there's a little rule, so we don't have to figure it out all the time, and it's called the cast rule. What this means is all trig ratios are positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. And because the reciprocals are just the reciprocal of the fraction, that means in quadrant 1, all the reciprocals are also positive, and in quadrant 2, cosecant is also positive because it's just the reciprocal of sine. Quadrant 3, cotan is also positive, and in quadrant 4, secant is also positive. But what we focus on here is the primary trig ratios. So all positive in quadrant 1, sine positive in quadrant 2, tan positive in quadrant 3, and cos is positive in quadrant 4. All right. So determine the exact value of the following. Well, sine of negative 4 pi over 3. That is a negative rotation, all the way up to here. And now if you didn't follow how I did that, remember, if we want to look at the principal angle here, since this one's negative, we could just add a complete rotation to figure out where that angle is. Common denominator would be 6 pi over 3, and that would be 2 pi over 3. So what we can look at, if we want to look at the positive one, this is the same angle, and that's at 2 pi over 3. Now, we got to remember the unit circle. Because this is a special angle, 2 pi over 3 on the unit circle, and we look at the y-coordinate there, and the y-coordinate, well, the whole coordinate is 1/2, and root 3 over 2, you can just reference your unit circle. So the exact value of the following would be the y-coordinate, which is root 3 over 2. I'm going to let you go ahead and do sec and cotan. They are both special angles, so you are going to reference your unit circle to find that. Remember, secant is the reciprocal of cosine, so it is r over x. Cotan is the reciprocal of tan, so it would be the x-coordinate over y. So one more time, you're going to take a look at the unit circle. You're going to find 315 degrees, and you're going to take the r, which on the unit circle is 1, divide it by the x-coordinate, and simplify that fraction, and you're going to find 270, sub in the x, sub in the y, and you're going to simplify that fraction. All right. Question number 2. If tan theta is equal to 3 over 2 root 5 and sec theta is negative, Then determine the exact value of sine theta. A lot going on in this question. When they're asking for sine theta, they are not asking for the angle. They are asking for the ratio. So we know that sine theta is equal to y over r. So what this question is asking for is that ratio. Whenever they say sine theta, it's a ratio. But if they were asking just for theta, we'd be looking for the angle. So it's really important that you read it that way. All right, I got to figure out where to draw this triangle, because when I'm looking for ratios, if I'm not using the unit circle, which I can't because this is not a point on the unit circle, then what I need to do is draw a triangle and get the ratio from there. So tan, this whole ratio here is positive, and secant is negative. Well, the cast rule doesn't work for secant because it's not one of the primary ratios, so this means the same thing as cos theta is negative. So if I take a look at my cast rule, C-A-S-T, tan is positive in quadrant 1 and quadrant 3. Cosine is negative in quadrant 2 and quadrant 3. So quadrant 3 is what meets both requirements, so that's where I'm going to draw my triangle. All right, so I've got a triangle. Now, I'm going to go back to the ratio of tan of 3 over 2 root 5. I know that tan is equal to y over x. So this means my y is equal to 3 and my x is equal to 2 root 5. But hang on, in quadrant 3, they're both negative. So I've got to put negatives here. It's a bit tricky. So you might ask, why is this ratio positive here? Well, think about it. If I had a negative divided by a negative, they would cancel each other out because a negative divided by a negative is positive. That's why the entire ratio is positive, but we have to put both values into the triangle as negative because we have to follow the rules for quadrant 3. Now, in order to calculate sine, I need an r value. So we have some tools for that. I'm going to use r squared is equal to x squared plus y squared. I'm going to put a little x here, a little y here, and I'm going to substitute negative 2 root 5 squared plus negative 3 squared. And that will simplify to 29. So r is equal to the square root of 29. Now, my last step is to answer the question. So I know that y is equal to negative 3, and I know that r is equal to the square root of 29. And just good practice here to always rationalize the denominator. And they're asking for an exact value, so I don't want any decimals. So we end up with negative 3 root 29 all over 29. Again, these are really important questions. It's a big idea for this section of the unit.